Okay, in this video we're going to look at how you can use samplers, and also we really need to explain what they are. But first things first, you will need version 1.6 of RUBE to do the stuff that's in this video, and you can check if you have that pretty easily by looking in the toolbar here, and you should see this icon. It's like a little grid, and let me just make this colorful here for you. So if you have this icon, you have version 1.6 and you can do all this stuff. And the original motivation for samplers was to have an auto trace feature, which is where you take an image and you can use that to automatically generate a physics shape for it in one automatic step. Makes things very easy. And typically the way that's done is you would have an image like this, which has transparency around the outside of it, and in the middle of it there's just one solid contiguous block of opaque pixels that we use to define an outline. And you would select one image like this and you would just work with that image to create a physics body for that. But as you know, in RUBE we can work with lots of images, so I thought it would be nice if we could have a system where instead of just one image you could make a physics body that used multiple images and composited them all together and use the outlines of those to create a physics body outline for them, all of the images as one thing. And along the way I also thought it would be nice if we could, instead of just using that composited image to create a physics body, we could actually like do a kind of a screen grab and make another image from multiple composited images. So just to give you an example of what I mean by that, this is a piece of a tree bark, and from this image here and this image here, that's a leaf, you can arrange them, when I say arrange I mean rotate, scale, change the aspect ratio, give them a bit of color tinting and so on, and you can put them all together. It's still just two images, but you can composite them in a way like this to make something that looks like a tree. And you can quickly change one of the image types to make another kind of a tree, and you can put them all together to make it another composite. So this is a composite of the composite. So this is where the idea of having a sampler to work with multiple images comes in very handy. So like I say, there's two main things. There's the creation of physics bodies, and there's just purely just the compositing of images. And there's quite a few steps to go through to get to the final auto tracing feature. And in this video we're going to look at all the gory details of those, but just as a quick overview of creating auto trace from, let's use this image here. We'll see, because I think most people may not actually want to watch a lot of this video as long as they know how to do this part. So you would have an image, drag an image into the scene, in images mode select that, and then in the action menu come down to sampler near the bottom, and right at the bottom of that menu you'll see create body and fixture from image. So I'll select that. You may want to watch the rest of this video if you want to know what these options here mean, but I'm just going to click through these at the moment, and I'll say no to keeping the sampler, and we'll see that that creates a physics fixture for us. Not really the greatest fixture in the world. It's kind of we've got a lot more points than we really need, but you can tidy them up in vertex mode like this, and you can also, if you see the rest of this video, you can see a few ways that you can tidy them up a bit better automatically as well. But yeah, that's now we have a physics shape like that, and it's part of that body, and it's all ready to go. Let's just make this give it something to collide against, so you can see that the physics bodies are there and they're working. And as an example of image compositing, as well as the one with the tree and the leaf, the bark and the leaves that I showed you just before, you can also make use of the way that you can now, this is also new in version 1.6, you can step the physics scene. So Tray Mills RUBE. I have here a scene that has a sampler in it already, and it's set up so that when we run the scene we see the wheels of the train moving like this, and there's actually some shadow images in there, so you can see underneath this bar at the top shadow is being put on the wheel there, and I'm stepping it round one step at a time here with the keyboard. But we can also run a script. This is like I say, this is new in 1.6 as well, so don't feel silly if you haven't noticed this before. We can do this thing here here, step all bodies, and number of steps, 60 steps would be 1 second at the default settings. I'm going to step it 3 steps, which is a 20th of a second, so we should see them bodies moving around just a little bit like that. We can undo and redo that. And in this scene I have set up a little script, and the script will do the stepping that we just saw there. So this is a 3 step, that's 20th of a second, and it will do that 20 times, so that's 1 second. So we'll have 20 frames per second, and the joint, these are being rotated by joint here. The joint is set, it's using a motor to rotate at 360 degrees per second. So this script here will step the wheels 1 full rotation in 20 frames, and then we're using this new thing here. This is a sampler, so you can see samplers are a fully qualified class type in the script, and we're going to write that to a file like this. So I don't expect you to worry to understand all this right now, but I'm just demonstrating how the image compositing can work with scripting and physics to save you some work, basically. So the goal of what I'm doing here would be to make animation frames for a sprite sheet where you would have 20 frames of animation for this wheel that you don't want to draw yourself. Basically, you want to put it all together and just have the program automatically generate them. So I'll just show you. This empty folder here was the one that was set to go into. So I will just run that script, and we'll have a look at how to move samplers, but just for now notice that the sampler is in this position. And if I open this file now with image viewer, whoops, sorry, and I move through these images, you'll see that we should have 20 images, and it just goes round and round in a loop. So you could use this for a sprite animation like that. Oh, it's a little bit choppy because I'm recording the screen. I think it was pretty smooth before. And because this is all automatically generated, it's it's not much work to change the position of the sampler, run it again, and then we'd have this running from a different perspective, a different piece of the screen. Yeah, so that's what I mean by image compositing, and I think it's pretty neat how you could get physics to run like that and use the scripting to get everything automated. Okay, so now let's get into the nitty-gritty of how you set up these samplers and how you would use them for yourself. I'm going to start with an empty scene. Yes, I am. Alright. To add a sampler to the scene, you add it the same way as you add most other item types. That is, you come into the Add submenu and you click Add Sampler. Where is it? That didn't get there. Oh, that was weird. Oh, I see. By the way, if you see this message here, that's not really a problem. Well, it's kind of a problem, but it's not a showstopper or anything. It just means that another script was running at the exact moment that you ran your own script. It can happen because the this script thing here has a automatically running thing that runs every few seconds. So if it coincides with that, you can find that your script or your action didn't do anything, but just try it again. Apologies for that. Okay. So this is a sampler here. It's just a rectangular area of the screen, and we can go into samplers mode here by hitting the P key, not the S key. Unfortunately, we're already using the S key for scaling. So we're doing P, and then when we mouse over this area here, we'll see that it highlights, and we can select it like this. And if we go into this items panel, we will also see that now we have another category here for items, for samplers rather, and we can select and deselect, and my sampler, give things names here, and if they're off the screen we can mouse over to see where they went. So that's basically the same as for other item types. Now, what exactly is this, and why is there nothing in it at the moment? I think we need to explain why this is called a sampler, and I actually struggled with what to call these when I was making this. I left them unnamed for a while actually, because like I said earlier, there's two main things. There's the physics auto tracing and there's image compositing. So there's the two main functions that this thing fulfills, but I didn't really want to give it a name that only has meaning for one of those two things, and I also thought it might be used for other things in the future. So I tried to get at the essence of what this area on the screen is doing, and so that's why I came up with the term sample, because that, for you non-English speakers out there, sample means that you just take a little piece of something and test it, basically, like that. So in the case of images, you would lay things out in a regular, evenly spaced grid like that, and you would look at each point and you would say, what do I have here? What do I have here? And so on. So in this example here, there would be 9 samples. And samples are, of course, given a value, or in this case, a color, and basically they would work something like this. We have our rectangular grid, and at each point or each cell in that grid, we look at what's there and we assign a value to our sampler like that. So that's what this this area on the grid, this area on the screen here is defining. The red and the green are just there to let you know which way is right and which way is up. So this is just to let you see the orientation of the sampler when you move it around. Right, so let's look at the properties of a sampler. And the the most similar other item in RUBE to a sampler is an image, because image is also kind of a rectangular area of the screen. So you'll find a lot of properties here are actually similar to images. So we have center, angle, and height in world units, and these three properties here are modified in the same way as we do for other items, especially images. So to move it, we use the T key to translate, like that. Rotation is with R, or like that, and scaling is with S, of course, like that, or like that. So that's exactly the same as for images, nothing too complicated there. The next thing that we need to look at is how do we make it a different size. I mean, we can scale it, but I mean, it's square to start with. And unlike images, there's no aspect scale that we can set graphically, because what we're doing here, remember, is we have a grid. We can't actually see it. There's an invisible grid here, and we're going to be filling in values like this in our grid. So we need to say how many values we're going to have, how many samples we're going to have width-wise and height-wise. So we can change it like this. If I say 350, that will change my aspect like that. So if I have, what would I have here? I don't know, 100. So you can see the height will always be a height in world units, and then the width will follow basically 3.5 times at the moment. So let's make this height of 1. So that's 1 world unit. As you can see, we're matching the same as the grid there, and then the width will follow from that. So if my height is 100 and my width is 50, then we'd get this result. So it's half a unit wide that way. So just keep in mind that you can scale graphically like this, but you can't actually change the aspect ratio graphically. You need to type your desired output values in here. What did we have before? 128 or something. Okay, moving along. We have an output file, and this, if we click on this button, we can choose an output file. I'm just going to call it out. Now nothing happened there. I'm just selecting which file the output will go to when I actually do the sampling. So if I look in my folder here, I'm not going to see that file here just yet. So let's bring an image in so that we can sample it, and we'll see the result there. So I'll bring my car body image again, and I will put my sampler out like this, about there, and I'll just set the angle back to 0, keep things easy to understand. The cursor out of the way. Okay, now we can use the sampler, and we'll use that output file. So we'll come down to the sampler menu and we can see here now that this top option is available to us. Write sampler output to file. And let me just bring my File Explorer window back. So it's not here yet, is it? Nope, not here. Okay, and if I write the output to file, we'll see, where is it? This one here. Okay. So now we have this image, and it's 128 pixels. It's a little bit smaller than I thought it was going to be. Let's make it a bit bigger. Run that again. Okay, that's what I was kind of expecting. Now let's shift those out of the way. And I'll just leave this image window here because this program will update it as we change it. So let's move the sampler around a little bit. I'll scale it down maybe. Let's put it there, and then I will sample again, and we should see what happens. You can see that this makes it quite easy to position our sampler somewhere and get a close-up view of somewhere or a scaled out view. So you can use this to upscale or downsample images. It's not really the best tool for the job, but you could do it. And we can also rotate. Notice that the sampler makes it look like it's going the other way. That's because, remember, the green arrow is up in the sampler. Yeah, so basically that's a simple example of sampling. Let me just put that back where it was. Now if we have two images in here, this is where things start to get interesting, because this is where we're sort of departing from the typical method of having just one image to do auto tracing and so on. So if I write this out to file now, we'll see we actually have another image in there. So you could manually do stuff like making some foliage for a tree. This is kind of along the same lines as the example with the tree, I guess. Very similar. And you could, make your image like that and sample that. And now you have a single image that you could use, which is a little bit more efficient, I guess, than using multiple images. And you can color tint them and rotate them and so on. Speaking of which, we have color tint in the sampler as well, I believe. Yes. So I could say make that a little bit blue, sample, and we have, oh, it's quite blue, isn't it? So we can set the color tint there, and we can change the opacity like this. And what else could we do? We can flip the output as well. Let's go back up here to flip the output. So this flips it vertically, yeah, rather than horizontally. Not sure why I decided to do it vertically instead of horizontally. There was a reason, but I forget. Sorry. So anyway, let's put these colors back to white and no flipping. And what else did we do? Oh, opacity. Opacity. Just putting things back how they were. Okay, so we're back to how we were. Right, well that's the basics of samplers, and that's the basics of image compositing, I guess. There's not really too much more to it than that. One thing to note though is that if you have a very large scene with lots of images that you want to like condense into a single image, as with the forest, remember the image that I just showed you before where there was like 10 or 12 trees in the background. Keep in mind that all of this stuff is scriptable. So what you could do is you could have, let's just pretend that this section with the trees here is an enormous forest. You could have some samplers that go along like this, and you could set the position of the sampler with script, so that it samples one here like that, and then it moves along to the next point like this in the next point in a grid, and then sets the file output name differently, and then samples again like this. And so you could build up a grid, like a background grid of images to load in as your background for your game, instead of using lots of tiny images. I didn't actually have a script to demonstrate that, sorry, but it's pretty straightforward. You can just set the position of the sampler and then change the output name, the output file here. This is of course changeable in script as well. So that's basically all we need to look at for image compositing, and the rest of the video we're going to look at the auto tracing stuff. So let's bring this sampler back up here, and I'll just get rid of this image. I'll bring that up here. Okay. Now in order to do some auto tracing, we need to find the outline of things in the image, and we need to define what we mean by an edge or a boundary that we want to trace around. And the typical way this is done is to use the alpha to use the alpha edges in the image, and an edge is where something changes from being 0 alpha to non-zero alpha, so it's changes from being transparent to opaque. That's probably the simplest way to do it, so that's what we'll do first. And the way we detect edges is by either clicking on the refresh now button here in the edge refresh property, or we can put a check in the checkbox here to do that all the time. Every time we change something in the sampler, like the position or the rotation and so on. I'm just going to, the first few times I'm just going to use the button here. So I'll just click the button, and you may not have noticed, but if we mouse over it, it's a little bit clearer to see that now we have some green markings showing over the image inside the sampler, at least. If we move the sampler away, we'll see that the edges are inside the sampler, like their coordinates are in the frame of the sampler. So if I rotate it, we'll see they rotate like that. And with auto refreshing off, you can carry the path that you got, or the edges I should say, that you got, you can carry them around like this. That's not too useful, so most of the time you'll want to have the auto checkbox on. The only time you probably don't want to have it on is when you're dealing with very, very large images, because the edge detection takes a little bit of processing, and when you're positioning images like this and you're like fine-tuning and scaling and doing movements like that, you don't want to be bogged down by waiting for that processing to occur. It doesn't take long, usually you know, less than a second, but it just sort of, it's a bit annoying if it's happening all the time while you're doing fine adjustments. So if I click refresh now again, we'll see that the edges are of course only within the sampler. So obviously we're not sampling anything outside the sampler, that's why it's called sampler. And so a result we get there is like this. Now if I turn edge refresh onto auto, we'll see that every time I move, the edges are being automatically updated. So you can see as we move out, or as we scale the sampler much larger, we're getting less quality of sampling. But that's okay, you may actually want that in some cases. And as we move it in, you'll see we're getting a finer sample of what's there, but it's not always useful. Like, as you can see, the finer we get, the closer we come to each individual pixel in the source image, and we start to see like stepping patterns like this. So it's not always that useful to have a sampler that has a higher resolution than the input image that you're sampling. Right, let's also look at how we can modify what we mean by edge. So at the moment it's pretty clear what an edge is. This part is opaque, this part is transparent. That's the edge, the boundary where they change. But what I wanted to do was make things a little bit more versatile, and to do that, or to demonstrate that, I'll use a different image. This one here. Let's make it a bit bigger. And I'll put the sampler on here, and let's see what we get in this one. Alright, I'll just how am I going to do this? Make that a bit smaller. Yeah, that's good. Alright, I'll just hold this over here, because as soon as I move it, the auto refresh is going to kick in. So let's just bring this over here. Now, what we're looking at here is, what I'm trying to show you here is the result of this setting here. Where is it? Alpha edge threshold. Now the default is set to 0.5 here. And to explain what this is, we need to look at what we have on the left here to start with. Actually, it might be a good idea to look at the source image first. And this source image, yeah, that's better. This purple block at the bottom is fully opaque, so there's 100% alpha there. The stripy S here, as you can see, we have a bit of fading out at the edges there, so it fades out fairly quick. This squiggly orange poo thing here is much lower alpha, so it's mostly transparent all the way through. And then above that we have a solid block of color that changes, and then we have a rectangle that fades into 0 alpha on the right hand side. So that's just a bit of background as to what this image is doing. So that explains why we have only half of the green rectangle has been considered to be an edge, or the edge is considered to be here. So this is the point where the samples in the underlying image crossed the boundary, crossed our threshold here from half alpha to less than half alpha. And likewise you can see, actually let's just look at it here. This is easier maybe. We can see that right here was the boundary in this image, this part of the image where the alpha crossed between 0.5 and less than 0.5. So we can change that to 0.75, and we'll see that things gradually shrink in. We only have a quarter of the green rectangle here, and now we can see that this part of the orange poo was the part that had the highest alpha. It wasn't actually too obvious to see that before, but now we can see. So that's what alpha edge threshold is, and we can use these lines to do auto tracing around. One property of alpha edges is that you always get a nice looping boundary. What we're going to look at next is using color edges, and you don't always get a nice looping boundary with that. Okay, now let's switch. I'll just put this back to 0.5. Now let's switch to using color edges, because this is another concept that's I think unique to RUBE and that you don't see in other editing programs like this. Let's move back over here. And when I switch color edges on, we'll see a couple of things change. One is that now we have these green edge boundary markings along the edges between different colors. We still have them around the outside on alpha borders as well. So that's one difference. And if we go back to our other image over here, now we'll see that instead of this section at the bottom being a solid block of opaque area, we can see that the edges in the color have also been picked out for us to use. So how are we going to use these edges? That's the next question. Oh, and we can also see a whole lot of messy stuff like this that's sometimes not very useful. This is why we want to have weighting. So if I move this out here, we can see that the green is only showing up well because it's shown over the orange, but when I move this out here, we'll see that those interior splotchy parts are actually very weak, so they're not going to factor too much into the next part of our process, which is the actual tracing of these edges. Right, back over to the easy example, and I'll turn color edges off again because that'll give us a nice easy to follow edge like this. And next thing we need to look at is how to set up paths. A path is basically a line that traces along these green markings. And to do that manually, we need to go into a separate mode, because it's kind of like the way you edit vertices in a fixture by moving them around. So it's like you're kind of editing the points along a polygon almost, and this requires a separate mode. And the way it works is you need to select one sampler, one single sampler, because we're going to be kind of stepping into the sampler to edit it. And we're going to hit the E key. Oh, was it mentioned in here? Begin. Oh, I see, yes. So if you have the context help up here, remember to keep this open when you're trying to learn new features, because it should it should have help in here to let you know what to do. So to hit the E key here, we'll begin editing control points. And when we do that, we'll see that we've entered a mode here where the rest of the scene is grayed out, and only this area inside our sampler is in the original normal colors. And we can use the escape key to exit this mode. So that's normal, and E is to edit the control points. Now I'll just leave this here so you can look at it while I'm talking about it, but basically you can look at the when you're doing this yourself, you can look at this to get a reminder of what to do. And the way this works is we click somewhere, and that will be a control point. So I'm going to click here. Now that's a control point, this red and white dot. It highlights yellow when we move the mouse over it, and we can move that when the mouse is over it to somewhere else. So I can put it here, I can put it here, whatever. I'll just put it there again, and we can see that there's a line stuck to my cursor now, and when I click somewhere else, I'm going to click here. Now you can see that the dotted line shows me the connection between those 2 points that I clicked. but the light blue line that was added between them is not going directly between my 2 points, because this line wants to go along the green edges of the image that was sampled. So I can move this inside, and as I move it in here like this, you'll see that what it's doing is it's actually pathfinding. So you could imagine that these green cells here are the cells in like a tile-based game that has pathfinding, and it's, like I said, it's a weighted search graph, and it's choosing the cheapest path it can to get between these 2 points, and cheap is where there's a lot of green. So if I move this over here, we should see it's cheaper to go all the way around here to get to there. So okay, I only have 2 points at the moment. Let's get some more points in. I could probably go all the way over here with that point. Yeah. And at some point it's actually going to be cheaper to come this way to get to my point. If you see what I mean here. It's this way we still go around to the anti-clockwise. This way we're going to start coming clockwise. We want to make it go anti-clockwise to give us a nice fixture, so I'll just put that in there. Now the third point I add, it's important to note where this dashed blue line is heading to on my existing points. It will go to the one that's closest to the mouse cursor. So when I'm here, it's going to go to the one at the top of the car, and as I move down here, it's going to go to the one at the bottom of the car. So at the halfway point it will cross over. So just be careful when you're adding new points. You want to keep them in the correct order. It may sometimes be easier to actually click somewhere close to the point that you want to add and then move it like this. So I'll just put another point here, and then the last point I can put here, or I can put anywhere along here. I could probably put it close to there. It doesn't really matter a whole lot, but just one thing to keep in mind is that the connection between the last point and the first point will be a single straight line when you're doing your auto tracing. So if you really want to make sure that you're getting a closed loop, you might want to put them basically like on top of each other like this. So I'll do that for this case. Now that is control points, and as you can see here, we can also delete the currently highlighted point by, see, I get this one again. If I hold the mouse over this so that it's highlighted and I hit the delete key, we'll see that that one is removed. But I didn't want to remove it really, so I'm just going to put it back. What else do we have? Delete, drag. Yeah, okay, that's everything. Right, so I'll hit escape to get out of this mode. And now when I move my sampler, I'll just bring it up here so you can see it clearly. We'll see that in this sampler we have a path in blue. And when I move the sampler, the control points move with it. So you can move it around so that they don't make sense much. And let me just undo. Just put it back where it was so it makes sense. And look at the properties. If you want to make sure that the path and the sampler move together, you can put them on a body. So I'll just add a body here, and this image will be attached to that body, and this sampler will also be attached to that body. So this is one thing I skipped over, didn't I? You can also attach samplers to bodies in the same way as you do for images, like this. So now when I move this body, the sampler and the image will move with it, and I can do scaling and rotating quite happily, and nothing will get messed up like it was just before. Okay, so paths. Let's have a look at a path. Select the sampler again, Now we have an extra bit of information here, and this is a path. Currently you can only have one path per sampler, but basically the path is this light blue line going around the outside. And I should also mention at this point that if these colors are inconvenient, this blue and the green for these cells, you can change those colors in the colors tab of the options dialog. So this is they are called edge texture overlay color and edge following line color. So that's green and blue at the moment. So if your image that you're trying to trace over was green or blue, you might want to make the lines red or yellow or something. So you can do that here. Alright, now what does a path have? A path has a property called type, which looks very similar to the type that you've seen in fixture types, and this property here is used when we create a fixture from this path. So it just lets us say what type of shape we want before we create it. We could change it after we create it, but it's just a little bit easier if we have this as a permanent setting in here and we always have it set to something. So here I'm just going to leave it as polygon, and radius 0, so it's just a normal polygon. And then we have these two properties here which are probably the most important, and they are max points and min angle. And you can see here that pretty much every part of this path that's not completely straight, so here's an example. Even though these are multiple cells in the search graph, because the program has detected that they're in a straight line, it's just made a point here and then a point here and cut out all the middle pieces to connect them. But where it comes across a point like this where it needs to change direction, it's keeping all of the points that hold information about changing direction, so it's not skipping anything at the moment. That's the default behavior, but that gives you usually way too many points, and also points that are not very useful, like this stuff here. We don't really need that at all. This could really just be one straight line across this section. So what we can do is we can use this slider to remove points to a degree that we find a nice middle ground where we have enough but not too many. Maybe somewhere like that would be kind of nice. So it turns out only 31 points is a good number for this polygon, at least in my opinion. And yeah, that should be pretty self-explanatory. The way it works is at any given time, when you go from, say, if we go from 30 to if we go from 31 to 30, come on, no, if you want finer precision, you can make this panel a bit wider, so we should be able to get 30 now. There we go. So what happens when I go from 31 to 30 is it will find one point, and we can actually see it there. Sometimes you can't see it because it's a small change, but this point here at the back is being removed, and the way it's deciding what to do, which one to pick, is it looks at the area of the triangle between three consecutive points. So that would be this point, that point, and that point. They make a very thin sliver triangle here with not much area, and all of the other triangles that are made by the other points here are of larger areas, so that's why it's deciding to remove that point. So that's how the max points works, and this is generally the most useful one because it does the best job of smoothly removing points so that it's not really visibly noticeable when they're disappearing, at least at the top of the slider. You can't really tell much difference. There is also here a minimum angle setting that's defaulted to 0, which means the smallest possible angle is 0, which is a straight line. So basically lets any angle through the check. We can generally these two sliders don't work very well together, so you either want to have minimum angle on 0 and then slide the max point slider, or you would want to have max points right at the top and you would slide the minimum angle. And the way this works is it basically just looks at all the angles that would be made by a point if it existed, and if it's less than this setting, it will be removed. So it has slightly different characteristics when you're moving the slider. You'll see sometimes not much will happen, and then you'll get to a point like there. So changing between 17 and 18 makes a huge difference. And generally this is not such a useful setting, but I thought I would leave it in here anyway. Could be useful in some cases, I guess. And the other characteristic is that you'll see that multiple points can disappear after just one click in the slider. So I go from 12 to 13 and we can see about a dozen points disappearing just in this little section. So that's slightly different to the way the max point slider works, which is always only removing one single point for each pip on the slider. I don't really think many people will end up using that min angle one, but never mind. Okay, so now we want to make a fixture from this, right? Eventually. So I'll put this back to, what did I have? 31, 32 or something? 31, 30. Let's make it 30. And now we can create a fixture from the sampler, which is the whole point of this exercise, isn't it? And the reason that's enabled at the moment is because I have a body selected. I'll just deselect that body so we can see that when there's no body selected, this menu item will be grayed out. That's because a fixture needs a body to go onto. You know that, right? You know about Box2D fixtures? Yep. They don't exist unless you have a body. And we also of course need to have a sampler selected, so if I didn't have a sampler selected, we would also see that. So I select a body, menu is still grayed out, that means I don't have a sampler selected. So you need a body and a sampler selected. I think I'll just add another body up here just to demonstrate that you can put a sampler onto two of them at the same time. So now I've selected two bodies, I select my sampler down here, and then I go create fixture from sampler, like that. And now we can see there's a fixture here, and only one fixture. Hold on. Oh, it only puts it on one body. Oh, my mistake. I thought it was going to put it on that body as well. I kind of think it should. Maybe that's a error in my script. Oh well, never mind. Anyway, so we have a fixture, and it's quite a nice fixture now. Nicer than the one that we had before. And because we made sure that our points were going around in a counterclockwise winding, we have been able to use the polygon decomposition routine that makes sub-polygons rather than just making everything triangles. So there you have it. That is a auto trace body. Well, it's not auto traced really because we kind of did it manually, but there is a physics body that matches our fixture, and we didn't have to place all those points manually ourselves. So that's kind of what the original one-step thing that we looked at in the menu here, create body and fixture from image. That's kind of what this is doing, but we just did it all step by step ourselves this time. So for a simple shape like this car here, if it's not too curvy, you might find it better to use the one-step solution there and clean it up a little bit. If you have something a little bit more complicated like this one, you might find it worth your while to do what we just did and make a sampler and use the sliders to get the number of points to something that you want. So I'll try that with this image, and I'll use this image to also point out the final option in this menu that we haven't looked at yet, and that is create sampler from image. So instead of using the add menu to add a sampler at the cursor position, we know that we want it to be for this image that we have selected. So we can just use this menu item here, and then if I go into samplers mode, we can see we have a sampler on this image already. So that just makes it a bit easier for us to do things like now we can do edge refresh, and now we can see that the edges are set up there, and we didn't have to actually set up this sampler or position it ourselves. And the way it works is that the sampler actually makes itself a little bit bigger. I think it's 1 pixel bigger than this image, so that we can get this the boundary between transparency and opacity and transparency here. If you make this sampler a little bit smaller, we don't get that. So we don't get any green edging around here. So if you don't want that, you may have to make your sampler a little bit smaller like that to avoid it. In this case I do want it, so I'm going to put that back on auto. Now why did I start doing this? I think it was just to demonstrate a more complex scene. Yeah. So obviously this is still not such a hugely complex situation. I wouldn't be too worried about doing this one manually, but actually let's look at a better example. Let's look at this one. Bring that one up. What are we doing here? Create sampler from image. Okay, so we have a sampler in here, and I'll put edge refresh on to auto there so we can make some edges. Now this is one where I wouldn't really want to do this by hand. Hang on. Let's make that again. Right. Yeah, so this is a bit of a complicated one. But what we can do is get our edges generated like that. Hit E to come into control point editing mode. Put a point somewhere. Put a point somewhere else. And then at this point we want to make sure it came around the right hand side. So we want it to be counterclockwise, and then I'll put a point somewhere else, and note that the blue line is going down to the first point I had. That's not what I want, so you have to be careful at this point. I'll bring it up here until it sticks to the point at the top. That's better. And now once again I want it to stick to the point at the top, and then I'll just put it here, and then I'll move it to my final destination there. So now you can see, once again, I only needed to put 4 points on here. Escape. And then I can bring this down, bring the slider down and put it to a point where I'm happy. Let's zoom in a little bit. So I could go, say, about here. Depends. If you're from England, you might want to make it more detailed. You might think it's not good enough with 200 polygons, 200 vertices. Right, 236, there we go. And then we can, of course we need a body. Let's put a body here, body with no fixtures. Select the body and then create fixture from sampler. So we have a nice fixture here. That's a pretty nice fixture, I think, and it wasn't much work to get it. So this feature, obviously, the more complex the thing you're trying to auto trace, the more useful it is. Right, this is a pretty long video, but we're still not done yet. You thought I was going to say we were done, didn't you? Sorry, nope. Because we haven't looked at tracing color edges yet. Basically, it works the same way. We put the control points down, and then the path will be traced along the cheapest route. It's just that the way what we consider to be cheapest is a little bit more complicated because it's weighted. So if I go back to here's a good example. Not sure if this is a great example, but I'll try this one. Let me just get rid of this stuff. Alright, so we have color edges off at the moment. If I turn color edges on here, we can see, as we did before, that instead of just the outline of the image, we also have the interior color edges are being detected as well. This is a pretty low resolution image, but it's good enough for demonstration, because what I wanted to demonstrate is that the weighting is different in different parts of this image. So at the bottom of the crankcase here, this is grey, this is light grey, this is kind of white. So there's not very many strong edges there. And if we bring this over, we can see that that part of the image is kind of white, empty. There's not much. There's stuff there, but it's not strong edges, so it's weighted very pale, very dark. Whereas on the other hand, we have a very strong edge here between the red and the white there. So that's weighted strongly. And the reason I keep going on about weighted here is because the weightedness of these edges is taken into account when we put a control point on here. And the best way to demonstrate this, and actually the whole reason I got this idea was from Google Maps. If you've ever used Google Maps to find where you're going, you may have noticed that it gives you two routes, or it gives you two options, or when you move points part way along the route, it will adjust your route to go through that point, which is kind of what I'm trying to do here. And a great example that I remember from when I was a kid was going from Waikanae to Upper Hutt. There's basically two ways you can go. One way goes over the hills here, and it's kind of windy and a bit slow, lots of ups and downs, and the other way is to go along the main highway and then actually come back. And you can see the difference in distance here. There's 60 kilometers and 37 kilometers, but if you look at the time, it's actually cheaper in terms of time to go the long way. and the road over the hills is not so cheap. So along the same lines, the way this works is you can treat these lines like roads. So a strong edge here would be like the highway, and these areas here with not much in them would be like going over the hills, slow country roads, narrow and winding and so on. So now let's put some points in here and we'll see what happens. Let's say we want to go from here to here. So what it's done there is kind of the same way that the Google Maps works. It's taken the cheapest in terms of greenness basically to get where it's going. And you can also oh, I've completely forgot to mention before, but you can, if you place your mouse, hang on a minute, let me just put this out here. I'll make a new sample here. Damn it. Hold on. Alright. Okay, so I have a sampler with a path like this. What I forgot to mention before was that if you bring the mouse close to an existing route between two paths, you'll see that the dashed line goes between both of those 2 points there. So it goes there like this. And if I click here when it's like that, I'll add another point between them. So I can bring this here, and I can bring this here, and I can bring this here, and so on. So you can add intermediate points in between the lines like that, in between the existing control points like that. So sorry about that, forgot to mention. Now this one, let's get rid of these. So in this example, what I was going to do here is that, let's say it's actually the cheapest way to go along the complete outside of the seat until we get to this point, and then we can cut into the hills, so to speak, and we'll come along this country road until we get to this point. And also on Google Maps, one neat thing you can do is, let's say I wanted to go somewhere and, whoa, what's going on? I wanted to go somewhere along the route. I wanted to go up here first. It will basically search for a route between here and here, and then to the final destination. So like this. Oh, come on, this is a, there we go, there's a good example. So this is basically, if you've used Google Maps to do this, you should have a pretty good idea of what we're doing with this path tracing in RUBE. So let's say I wanted to go along the bottom of the seat. I can bring my mouse here so that it is over the it's kind of sticking to the lines here, and then I can click and bring it here. Wasn't quite good enough, but we can do that maybe a couple of times, and that's not what I wanted. We can get the route to come along between the seat. This is not a very good example. I have a better example over here. Let's try this one. And I just kind of stole this off somebody's website, so I hope this guy, let's not use that one. We'll get rid of some of those. Edge refresh. This guy, let's sorry, AJ Karat, that's the guy, hope he doesn't mind. Now I haven't turned color edges on here yet, so you can see that it's because this image is fully opaque all the way around, the only edges that are being found are at the top edge and the bottom edge. So that's the only choice it has to follow. When I turn color edges on though, we'll see that now it can follow around the strong edges in the image. So it totally depends what kind of image you're using as to whether you can actually do this. Like we just saw, the one with the motorbike was a bad example. This one is a pretty good example because we can put our points like this, and the strong edges, it's very clear where the highway is in this example and where the country roads are. There's a little country road shortcut there, huh? We don't want to take that. There we go. So this is a good example because the edges are quite strong. The grey is quite different to the pale orange, so it works great here. A really bad example would be something like this one, which doesn't have many. It has a few decently strong color edges, but not really enough, because there's also the problem is that this background also has color edges in it as well. So just keep in mind, some images are never really going to work very well with this, whereas other ones will work pretty well. Well, I think that will cover it for how to use samplers. Quite a lot of information to take in, wasn't there? As always, there is a fair bit of help in this built-in help here, so I would encourage you to have a look at that. Under editing items, editing samplers, I actually had to extend this into 1, 2, 3, 4, 5. There's actually 5 separate pages here. That's how much there was that's how much information there was to convey. And I think also the problem is that it's a sort of a unique concept that at least I haven't seen in other editing software. So putting that together, it's turned out to be quite a lot of information to make a video about. But yeah, just have a look in here, and if you have any questions, just give me an email or post in the forums, and we'll see if we can figure it out for you. So thank you for watching. I hope you had a good strong coffee before the beginning of this video to make it through. See you later.